Hi everyone. In today's class, let us discuss open and short circuits in parallel networks. Objective: at the end of this video, you'll be able to measure the voltage and current in open and short circuits in parallel circuits. Parallel circuits. Parallel circuits are those where the input voltage remains the same across all branches, but current is divided at each branch depending upon its resistance value. Let's discuss open parallel circuits. Let two resistors R1 and R2, each of 10 ohms, be connected in parallel. Connect the two ammeters A1 and A2 in series with the resistors R1 and R2 respectively. Let the ammeters A1 and A2 be of the moving coil type and range between 0 and 5 amperes. Connect a DC voltage source or battery with 12 volts, a switch S, a common ammeter A ranging from 0 to 5 amperes, and parallel connected resistors all in series. Connect a moving coil voltmeter ranging from 0 to 20 volts in parallel to the circuit. Close the switch S and note down the voltmeter and ammeter readings. Check the readings with the given tabulation. Now verify the measured value. Since the resistors are connected in parallel, substitute the values in the formula I upon R is equal to I upon R1 plus I upon R2. I upon R is equal to I upon 10 plus I upon 10. R is equal to 5 ohms. Substitute the values of resistance R in the Ohm's law formula I is equal to V upon R. I is equal to V upon R is equal to 12 upon 5 is equal to 2.5 amps measured by the common ammeter A. Calculate the current I1 and I2 flows through R1 and R2 respectively. I1 is equal to 12 upon 10 equal to 1.2 amps. I2 is equal to 12 upon 10 equal to 1.2 amps measured from the ammeters A1 and A2 respectively. When you add I1 and I2, we get total current approximately of 2.5 amps. Compare the calculated values with the measured values. Let us make an open circuit by removing the resistor R2 alone at branch 2. Now close the switch S, note the voltmeter and ammeter readings. The voltmeter reads the same as 12 volts. Since branch 2 is kept open, no current will flow and there is no ammeter reading at A2. Ammeter A and A1 alone will show the deflection. Since only one resistor is present in the circuit, the total resistance of the circuit becomes 10 ohms. So, we get the current as 1.25 amps alone. So, in parallel circuits, if any branch is kept open, it will not affect the other branch's current. That's why usually all the connections in your home are connected in parallel. Let us discuss using lamps. Connect 3 lamps L1, L2 and L3, each 40 watts, 240 volt, connected in parallel. Energize the circuit with a single phase AC voltage source. Ensure all the lamps are glowing. Switch off the circuit and remove the lamps L2 alone. So let branch 2 be kept open. Switch on the circuit. You should see the lamps L1 and L3 glowing. This shows that in a parallel circuit, if any branch is kept open, other branches will work as normal. Let us discuss short circuits on parallel networks. Caution: making short parallel circuit is highly not recommended because this poses hazards to equipment and human beings. Let us discuss the short in parallel circuits. Let the three resistor values of R1, R2 and R3 be 50 ohms, 100 ohms and 150 ohms respectively. Connect ammeters in the A1, A2 and A3 series with resistors R1, R2 and R3 respectively. Let the ammeter ranges be 0 to 200 amperes. Connect a common ammeter A with a range of 0 to 500 milliamps in series to the circuit. Connect 12 volt battery positive terminal to the common ammeter via switch S and negative terminal to the other end of the circuit, common point of R1, R2 and R3. Connect a moving coil voltmeter 0 to 30 volts in parallel to the circuit after switch S. Close the switch S. Note down the reading of ammeters and voltmeters readings. Verify the measured values as follows. Let's find the current through each resistor using Ohm's law. I1 is equal to V upon R1 equal to 12 upon 50 equal to 0.24 amps or 240 milliamps. I2 is equal to V upon R2 equal to 12 upon 100 equal to 0.12 amps or 120 milliamps. I3 is equal to V upon R3 equal to 12 upon 150 is equal to 0.08 amps or 80 milliamps. When we add all three current ratings, we get 0.4 amps or 440 milliamps. Verify the current value I, I1, I2 and I3 with ammeters A, A1, A2 and A3 respectively. Now take a hookup wire with enough length to make a short at branch 3 where the A3 and R3 are connected. You could see an ammeter needle A immediately read a full-scale deflection due to the high current. Ammeter A1, A2 and A3 will show 0 readings and a voltmeter measures the same as 12 volts. This current will not flow through the resistor R1, R2 and R3 because current will always flow at easy path. Since no current flows towards the resistance, total resistance becomes less and current increases. Note, while doing short, parallel circuits always use a series resistance R as shown in the circuit diagram. I hope after watching this video, you will be able to measure the voltage and current in open and short in parallel circuits.